Hello guys, welcome for joining our session today. We will revise today for the quarter 4 exam. Let's begin with the first question, which is finding the interval on which the given function f(x) equal 1 over x to power 2 is increasing or decreasing. As you know at the beginning, before we find the critical number or we find anything, we have to find the domain. The first step, as usual, I have to find the domain. What is the domain of this function? Domain of this function, x not equal 0. It means all of the values of x except x equals 0, the function undefined at x equals 0. It means the function defined at all of the values of x except x equals 0. So 0 here, the function undefined at it, and impossible to be critical number. Impossible to be critical number because the function must be defined and continuous at the critical number. Okay? Look here, I have to find the first derivative as usual. Okay, but I need to rewrite the function bx to power negative 2. It is impossible at the beginning or before we begin to solve any problem. If we have a rational number or a rational function or anything, I have to find the domain first. Okay, look, it will be negative 2 x to power negative 3. Rewrite the function to be in the simplest form. It will be negative 2 over x to power. As you know, to find the critical number, we find the values of x at which the first derivative equals 0 or does not exist. Equals 0 if the numerator equals 0, does not exist if the denominator equals 0. Here, in this case, we, as you know, we will find the critical number where the first derivative does not exist. Here, we don't have any values of x which makes the numerator equal 0, so we don't have any critical number at which the first derivative equal 0. We will find the critical number where the first derivative does not exist. Here, to find the critical number, first derivative does not exist. If x to the power 3 equal 0 implies x equal what? 0. But x equals 0 not included in our domain. We can consider it as a critical number. No critical number. There is no critical what? Number. We don't have any critical number because the function must be defined as the critical number. Now, we will draw the line for the first derivative. I put every time on this line the critical number or the values at which is the function undefined or the value of the function undefined. Here, f(x) undefined, okay, at x equal what? 0. When we draw the first derivative, I have to write what? On this line, I have to write the values of critical number and also the value at which is a function undefined, which is what here? 0, not a critical number because the function, that is the definition. Function must be defined at this value. Negative infinity, and here what? Infinity. Okay? Then use the test value. Here I choose negative 1 and here I will choose what? 1. Replace in the first derivative because if the first derivative positive, the function is increasing. If the first derivative is negative, the function is decreasing. Replace in this one, it will be negative over negative, it will be positive. So in this case, the function is what? Increasing on this interval. Replace in the first derivative, it will be negative, so the function is what? Decreasing. It's so easy to find. Increasing on which interval? On what? On negative infinity and what? 0. decreasing, decreasing, on which interval? 0 and infinity. It is as the answer which I give you. This one, it will not be given, but it is the answer to help you. You have to solve, and I give you this part just to check your result. Okay, so the function is increasing on negative infinity and 0, this open interval, and decrease on the open interval 0 and infinity. I hope you understand. Please, before you find the first derivative or do any steps, you have to find the domain, especially if we have a rational function at this one or radical function. You have to find the domain to know we have a critical number or no. In this case, we don't have a critical number. Why? Because the function already undefined at it, and the function must be defined at the critical number. Please revise all of the sheets which I give you before on increasing and decreasing. Okay, watch all of the videos which already I posted on the LMS to remember everything. Okay, here for the second question, as you see here, find also the interval in which this function is increasing or decreasing. But as you see, the given function in this case is polynomial function, and as you know, the domain of the polynomial function, domain here, the domain of the polynomial function is what? Is the domain is all real number. So any values you will find at which the first derivative does not exist or equals 0, it will be critical number. Since we are talking about the interval on which the function is increasing or decreasing, we will use the first derivative test. So I'll start with the first step, which is what? Find the first derivative of the function, which is here, 3x to the power 2 minus 6x. The second step, I have to I set the first derivative equal 0. Why? Because it is a polynomial. I will find only the critical number at which the first derivative equals 0, since we are talking about a polynomial. Okay, in this case, 3x to the power 2 minus 6x equal 0. By factorizing, I will take 3x as a common factor. It will be x minus 2 equal what? 0. Find this mean x equal 0 or x equal to critical number, because both of these value in in our domain. So we have two critical number. The third step here, I'll continue in any empty place. I will use the number line, and here negative infinity, and here, since the function defined at all, I will not write more than the critical number. Here 0 and 2. So choose the test value which help me to identify the sign of the first derivative, because I don't care about the value of it. Here I will choose -1, here we will take 1, and here we will take what? 3. Replace in what? In the first derivative, this 1. It will be a negative multiply negative, it will be positive. Okay, so the function is what? Increasing. Increasing. Replace by 1 in the first, use your calculator, but I find it mentally, it will be here negative, so the function is what? Decreasing. Replace in the first derivative also, it will be what? Positive, so the function is what? Increasing. In this case, function increase increasing, okay, on which interval? On this interval and this interval, which is what? Negative infinity and 0. The second interval is what? 2 and infinity. But the function is decreasing, decreasing, decreasing on what? 0, open interval 0 and 2. Check your result with the result, this one, just to check only, to check it is correct. Okay, if we talk about increasing or decreasing, we use the first derivative. Okay, I hope you understand. You understand everything. Now, here, please read the head of the question well. Okay, here, he asked me, find the values of x that give relative extrema. Here he asked me to find only the value of x. He didn't ask me to find the point, x and y, only x. What is the meaning of relative extrema? Relative extrema, it means relative maximum or relative minimum. And as you know, extrema occur at what? Critical number. For this function, since our given function is a polynomial, so our domain all real number. The function defined at all of the real number. So, in this case, to find the relative extrema, we have two ways to find it. We can use the first derivative test or second derivative test. Okay, here, I'll use the first derivative test because all of you know how to use it well. Here, find the first derivative. Here, it will be 15x to power 4 minus 15x to power 2. Since we have a polynomial function, we find the critical number only at the first derivative equal what? 0. Does not exist. By setting the first derivative equal 0, okay, to find the critical number, because we have only one case, 15x to power 2, factorizing, it will be x to power 2 minus 1 equals 0. Critical number here, critical number, x equal 0, or at x square minus 1 equal what? X square equal 1, x so equal positive or negative 1. So what are the critical number? Critical number x equal 0, negative 1, 1. Okay? Then use the test as you know. Here, negative infinity, and here what? Infinity. Write the critical number or the values at which the function undefined, but here the function defined at all of the point in our domain. Here we write negative 1, 0, and 1. Okay? Choose the test value that is for first derivative, as I told you, the first derivative. Negative 2, I choose negative 2, negative 0.5. Okay, I choose here 0.5 because I have to choose any value, but it is better to use 0.5, not 0.25. Okay, here I'll choose 2. I replace in the first derivative. But for me, because I solve it mentally, but I use this form. I use this form. Okay, here negative 2, it will be positive, positive, it will be here positive. So the function is what? Increasing. Negative 0.5, you use the calculator, it's so trivial for you, but don't forget, when you replace negative 0.5 or any negative value in the function, in the first derivative, between two brackets. It means 15, if open bracket, negative 0.5, all to power 4. When we read the power to any value, please put it between two brackets, especially if it is negative. It will be negative, so it will be decrease. Negative, it will be decrease. I already solved it and I know what is the value. To save the time of this session, just replace in also the first derivative. It will be what? Positive, so the function is what? Increasing. Okay? Here, as you know, the extrema occur at the critical number. That is the first condition. The second condition, the behavior of the function change around this critical number from increasing to decreasing or from decreasing to increasing. At the critical number -1, as you see, the behavior of the function, it changes from increasing until reach to the greatest value, then become to decrease. In this case, we have what? Relative maximum at -1, at x equal what? -1. Clear? At 0, it is a critical number also, but the behavior of the function does not change around it. Decrease, and here what? Decrease. So at 0, no extrema, because the behavior of the function does not change. As I told you, what is the meaning of extrema? It is the extrema, where the extrema occur. We have two conditions at the critical number, and the behavior of the function must be changed around it. At 1, as you see, look here, the function decrease, then become to what? Increase. Decrease before it decrease, and after it increase. This point here at which decrease until reach to the least value, which is the minimum. So relative minimum, okay, at x equal what? 1. So what is the result? Relative maximum at -1, relative minimum at x equal 1. That is why we choose what? B. I hope you understand. Extrema occur at critical numbers such that the behavior of the function change, okay, from increase to decrease or decrease to increase. If the function does not change, so we don't have extrema at this what? Critical number. I hope to revise all of the lesson before solve this sheet. Okay, here, I think it's so easy. Look, please try to focus with me. Find the interval in which the graph of the function of x equal x power 4 minus 4x power 3 plus 2 is concave upward or downward, then find all points. Look here, points. What's the meaning of point? X and y, okay? Of inflection for the function. Before we begin to solve this problem, I have to remind you. If we talk about the concavity, we talk about the second derivative. If the second derivative at a point in interval positive, okay, if the greater than 0, so the function concave upward on this interval. If the second derivative at a point, C for example, okay, in an interval less than 0, it means the function concave downward. When we talk about concavity, we use the second derivative, okay? Also, what is the meaning of inflection point? It means the values of x at which what? Not point. Yeah, I have to find the value of x at which the second derivative equals 0. If the behavior, that is the first step, and if the function change the concavity around this point from concave upward to downward or from downward to upward, it will be inflection point, okay? Otherwise, no. Look here. What is the first step? Please focus. Study the steps, just to follow the procedure. Find the first derivative, which is what? 4x to power 3 minus 12x to power 2. Okay? Means, but in concavity, I'm talking about second derivative. I have to find the second derivative. How to get the second derivative? By differentiating the first derivative, or apply the basic rule of differentiation on the first derivative. It will be what? 12x to power 2 minus 24x. Then Third step, I have to find the values of x. Value of x at which the second derivative equal what? 0. Which may be at this value of x we have inflection point, maybe not, because another condition changed the concavity. Take 2, I'm right here, no, 24, I'm sorry, that is 24. Take 12x as a common factor, it will be x minus 2 equals 0. So x equals 0 or x equal 2, maybe one of them or both of them are inflection point. Then use the second derivative. Here I use what? Second derivative. Look here, choose the number as I did. In the first derivative, I will do with the second derivative. Write here 0 to the values at which the second derivative equals 0, which divide the domain into intervals. Select the value. I'll choose here what? -1. Here I'll choose 1. Here I'll choose what? 3. Then replace in the second derivative. Second derivative. Okay, I choose -1. It will be positive. The second derivative positive, sorry, not increasing. I'm so sorry, not increasing. I'm talking about concavity. Positive second derivative. Positive, it means concave, upward. Okay? By -1, I replace by -1. Negative, it will be, wait. Negative, and here, negative, no, here it's positive, right. By 1, it will be positive, negative, it will be negative. Okay, concave down, just replace. I solve it mentally. Positive, it will be positive, second derivative positive, so the function is concave, upward. So right now the interval in which is the function concave upward or concave downward. Here, concave, upward, on which interval? On which interval? That is the first one. The upward, here upward. Okay? And negative infinity and 0. And another open interval which is what? 2 and infinity. Concave, downward on what? 0 and here. And 2. I hope it is clear. As give, concave upward on this interval and concave downward in this one. Look here. To know what is the inflection point, the values of, look, to condition. The values, okay, of x at which is the second derivative equals 0 and the function, the second condition, the function change its concavity. At x equals 0, the second derivative equal what? 0. And the concavity change from upward to what? Downward. So we have inflection point, look here, inflection point at what? The first point 0 and f what? 0. And the other point is what? Here to the change of concavity, yes, downward to upward and at 2 and f2, f at 2. By replacing it will be at 0, f0 it will be 2. And just replace to find here the coordinate, the y coordinate of the inflection point change in the original function. And what else? To replace by f2 here, it will be -14. So that is my result. Again, concavity, second derivative. I have to find the second derivative. How to get the second derivative? By differentiating what? The first derivative. Then find the zeros of here zeros because I'm talking about polynomial. I'll find where the second derivative equals 0 or does not exist. But since we are talking about polynomial function, I will find the values of x at which the second derivative equals 0. Maybe at 0 or 2 we have inflection point. At both of them or at one of them maybe I don't have. That is depend on the concavity of the function. If it changed around any one of them or both of them, so they are inflection point. Here we identified what is the interval in which the function concave upward or downward by using the second derivative, okay? Inflection point, the values at which here, point means I have x and y coordinate, okay? The two coordinate here at 0 and the f at 0. How to find f here? F, not fa, first derivative. I have to replace in the original function to find the y coordinate. I hope you understand, okay? Here it's enough in this session to solve this number of questions. Thank you for joining the session and watch the video. Wait for me for the second session for revising the sheet or revising for the final, to revise for the final exam. Thank you, bye-bye, and have a nice day. Bye-bye.